This is section 15.11, acquiring a carbon-13 NMR spectrum. Something nice about carbon NMR spectroscopy is that instead of worrying about three major components of the signal, the shift, the integration, and the multiplicity, in carbon NMR, we only worry about the shift because the signal and the multiplicity are not factors in these resonances due to some complex physical and mathematical reasons. For instance, the pulses that we use to generate the resonances in carbon NMR aren't typically long enough to allow us to actually integrate these signals, and the splitting gets super complicated because even though it's very unlikely that a C13 atom is a direct neighbor to another C13 atom, C13 is likely to be a direct neighbor with a proton, and even protons 3 carbons away can split them. So we just collapse them all down to singlets using some very sophisticated physics. And so all we're left with are singlets, as you see in this spectrum. So typically what we are relying on is matching the chemical shift of a certain resonance to what it might be in the functional groups. And functional groups have key resonances that we expect to see, and we'll go over those in section 15.12. But all that we need to know is for 15.11, how to acquire a NMR spectrum is that we perform the measurement in the same way as a proton NMR spectrum. It's just that we're looking for different things. And this was section 15.11.